Alright, today I'm going to be virtualing Codeforces around 575 version 3. I've changed some of the audio, so uh, my voice will probably be clear. Three piles of candies, three candies, uh, all takes one large pile, well, taking the candies, piles, number of candies equal, so what's this? One, three, four. The third pile, the second pile, only candy equals to one. Choose the second pile, choose the first pile, third pile divided by 54, and now it's 646. Q and then long ABC. Is it better for Alice to just take the maximum, no matter what? So if Alice takes this 100, or is it better for them to take the smallest two and then leave the biggest one? I think the smallest two, right? And just read long. If diff is greater than or equal to C, then A turns into B, and then what we output is A plus the remaining, so C minus, no, diff, wait, no, this is smaller than equal, yeah, C minus diff over 2, otherwise, we can just output A plus diff, A plus C, right, yeah, lung cancer test 2, let's see, or should we do like a brute force on this? Steps first, CB, and then series, max, answer, rest. B, C, and okay, and then our rest. Okay, so we return this, or we return this. Uh, mm, C2. So A is C0, B is C1, and C is C2. Or how about this? We just do this. B, C. Yeah, we choose every possible position for A and B. If A is greater than B, we can swap them. Odd sum segments. K non-empty, non-intersecting subsegments. So we split into K parts. So K minus 1 cuts, such that each segment's odd sum. Okay, it's odd. It's possible to rearrange and shuffle the elements of a given array. So basically, can count the number of odd ones. So here it's we gotta output this. What's the output? Okay, so always somebody should use it in. So is it so you oh it's impossible to double elements. Okay. So we can just be greedy, right? Just one and then once we get here it's another one and then finally it's this one. Over here we have one, two, three, so it's not four. So it doesn't work. Over here it's one, and then over here doesn't work. Okay. So we can just take it mod two, right? Yeah. And then whenever we get to a one, we can stop. Okay. So first you gotta greedily get the answers. So these are the indices where it's one. Um, if there was no restriction, okay, if what's that size? Oh, so let's see. It's one, two, so one, two, three, so that would be three. So there would be three positions. Or position dot size. Mod 2 is not equal to k mod 2. Then we output no. Because in the end, if you have like more, for example, you have another one and then another one, you can just combine these to make it like this. So five elements at the end and it'll work fine. But if it's only another one, you can't make it work because then over here will be even. Um, while it's greater than k, um, let me see out. So first, the special is one. We gotta start with one. Or actually, we can just do it this way. For int I is 0, I smaller than k minus 1, I plus plus, cout plus I plus 1, and then in the end, we cout n. Because in the end, we need the entire array. 115. position I plus 1, yeah. Oh, here. Don't feel like this right. I'll do some more testing. Um, so 3, 1, 2, 1, 3, 1. Oh, I forgot. You gotta add a test case in there first. 1, 3, 7. What if it's like 1, 3, 1, 0, 1, 1, 1, 0, 1, 1, 3, 7. 1, 2, 3, 7. Okay, and test 1. Oh, I forgot to output yes. Let's see. And robots have escaped from a laboratory, so find these robots. Okay. You still have some control. Oh, so you know the location, and so you know the coordinates. You may send exactly one command to all of the robots. Essentially, robot cells in 2 cases. You're not getting closer. Yep. So each robot can reach the point X4, and it's asking if it's possible to find such a point. Uh, it seems okay. So basically, you have some boundaries. Can we check every point? Is that okay? Well, n is to 10 to the 5. Okay, we should have some x and y restrictions. So int min x, 189, max x, negative 189, um, uh, uh, min y, 129, max y, or lx would be better. Ly and k. And then for every robot, we have int x, y, f1, f2, 3, f4, And then if F1 is 0, what does that mean? If F1 is to the left, right? So basically you can't go to the left, so our LX is max LXX. If F2 is 0, so you can't go up. Yeah, so wait. So you can't go up, so there's a limit to the max. And if F3 is equal to 0, you can't go right. So there's a limit on this. And then if F4 is 0, that's the last case, so this. But just y. And then if Lx is greater than Rx, or Ly is greater than Ry, we can output 0, else we can output 1, and then Lx and Ly. Because it would always be valid. Is there a limit to the output? Should not exceed -1 then we have to change this to, that is the max anyway, so it's okay. 2, 3, 4, okay, accepted. D1, D2. Should I go for D2 first, or it's the size of the input? Okay, so this is n squared. This can be n squared. I'm doing okay. 43. Let's read the statement first. String S, it's RG or B. You have an integer k, change the minimum number of characters in the initial string S, so that after the changes there will be a string of length k. That is a substring of S, and it's also a substring of the infinite string RGB, RGB, RGB. So what does this mean? Change characters. So there's a string that has of length k that's a substring of S, and it's also a substring of S. So basically there exists a string of length k in S such as RGB, 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 and so on. Okay. Uh, okay, yeah. Um, okay, there's a easy one for the easy version. So all I have to do is iterate over all of these strings, and then you find the difference between the cycle and that. Yeah. Uh, but I think you can do D2 also. All you have to do is I'll just change it in O1 from the previous state to the current state. But first, need a solve function, wait, or a calculate function. or actually, I'll move it outside for now. Int start start is R, start is G, and start is B. Okay, for int I is 0, I smaller than k, I plus plus. Um, if I mod 3 is 0, if si is not equal to r, then r will have to plus plus. If si is not equal to g, sg plus plus. Si is not equal to b, sb plus plus. That's 3 is 0. Mm, this is not equal to, oh, it's 1. Okay, it's not, it's 1. After R is G, right? Okay, so we shift everything up by 1, right? After G is B. Okay. Blue is red. Then it's B, R, G. B, R, G, okay. And so first we have our original answer. Okay. Oh, shoot. There. And then for each I is K, I is more than N by plus plus. In the end, we can just output this answer. Okay. And we gotta okay, and answer. So after we change the values, we can do that. How do you change it? Okay, if, well, basically it's the same thing over here, right? And then over here we just do I minus k. And then also we're removing it so it's minus minus. Three, two, three. How to get that? ERG should work, right? Okay. Do some testing over here. 4, 2, 4. And then the opposite. Did I? It's N. Oh, I did. I did it. 3, 1, 0, 2. Okay, over here. Let's see. 1, 2, 1. Red. It's RG. Yes. And then for G, it's GB. So GB is 2. And then BR is 1. Okay. And so once we get to here, the last one got updated to 0. What's the last one? The last one was B. So once we got to here, I is 2. So 2 minus 2 is 0. Right. BGR. BGR. 0, 1. Wait. Over here. Yeah. So since it's 2, if this is not equal to G, then it's plus plus. So it's not, okay. And then back, if, so it's 0, is this is not equal to B. Oh, that's I minus K over there. This works, it should pass both D1 and D2. So it's effective for D1 and D2 as well. So this is just simple cycle, yeah. Just gotta change them to a cycle. So you do a O1 change from the previous state to the current state. Okay, yeah, I'm doing really good right now. I'll try to start E and then maybe F. Connected component on the chessboard. Two integers B and W. The cell 1 is painted white, so first it's white. Okay. It has to find a connected component on this chessboard that contains exactly B black cells and exactly W white cells. Two cells are called connected to share a side. Um, okay. Well, so basically you find something in this grid such that it's black and white. You only get B and W. Oh, it's a chessboard, so it's white, black, white, black, white, black, alternating. Okay, yeah, that makes sense. Um, so first off, the difference between E and W should be E black cells and no white cells. White, black, white, black, white. So if it's 1-1, it's 1-1, okay. If it's 1-4, so 1 black and 4 white, right? How do you do it? 2, 3, like this one? Oh yeah, because you have top. So there we go. We have 3. and then 2, 5. You can do the same thing over here. So we have this, and then we have these. So, okay. Uh, third, oh, you gotta construct it. Um, yeah, I don't really have any ideas for this problem. I guess you could split it into if b is greater than w and if b is less than w. Or how about this? We have first is 1, 1, so 1, 4. First we do this, then 1, 4, so we take one in the middle, and then we need 3 more white ones, so we have 3 right here. And if it's 2, 5, we can take these two and these two. And we need 5, so we have 1, 2. And over here we have 3. Yeah, 3, we need 3 more. Vector should be pair. Right? It's a good thing it's a 1e9 times 1e9 set. Current is, say 1e5, 1e6. Um, I'll change it to long, long, so it doesn't like go overflow if that happens. Probably won't. E minus minus, 2e minus minus, insert dot pushback current 6, insert dot pushback current, and then store the black and white ones. First row is white. Okay, so first row with even. So we start in an even row, so like this row for example, and we start in an even value, or this row for example, and then 1, 2, 3, 4. So we start like this. So if current mod 2 is 0, then we're starting at white. So current otherwise we can just reverse it. So if it's the first one, we can black dot pushback. So if it's the first one, it's like this, like this. The black one is current minus 1, and black one, yeah. And why? Oh, wait. Why does why does this? What iterations? It should be min bw if answer dot size because it's 2 times talk iterations. Then we can add the final ones. So in the end, if current mod 2 is 0, for example, let's see, current plus positive, and current is mod 2 is 0, so right, 1, 2, 3, 4, 1, 2, 3, 4. Then the next one will black will be the one under, so current plus 1 and 1e6, and black will be current plus 1 and 1e6 plus 1. Okay. So right. 1, 2, 3, 4, 1, 2, 3, 4. Okay, otherwise, so if it's like this, then it's reversing the orders. While D minus minus, answer dot push back, black dot black, black, and then black dot back, while blue minus minus. If black dot E empty, output no. If white dot empty, output no. Otherwise, answer dot push back, white dot back, and white dot pop. Okay. And then now we can output yes for auto P answer. Output P dot first and P dot second. Two. I'm gonna turn test two. Okay. That was expected. If I do two, the two black ones, 1, 2, 3, 4, 5, 6. That's a yes. If I do two, 1, 1 0. Wait. Oh, 1 0 didn't work. Uh, if x1. If in the end it's if else see it now. And over here it's practically the exact same thing. Zero, 1. And answer on test 2. There's a lot of wrong answer on test 2. I think that's it. Just go to what about F? Let's read F. The cave's smallest shortest path from I to J and from J to times 1. Only if D is the matrix of shortest paths, while Dij is the length of first path between Ij. The kth element is sorted array consists of Dij. You need to print the kth element in the sorted array consisting of all Dij. Is it binary search? Because I think it is a thing of binary search. You can search for this D, so you can search for the answer basically. And it's not like it's queries, it's just one. You need distance from everything. Well, the brute force would be to just construct a D array, but it's kind of slow. Okay. K is at most 400. K is at most 400. Is that something that's like good? Um, Is it possible for us to like stop at some point? Like, yeah, we can, right? If we do like fluid wash or something. If it's already greater than, then we don't need to do it anymore. Like, we don't need to calculate it. We only need the first case smallest ones. I think there's a better implementation technique than this. Okay, so we can do x, x, x. Oh, so we look at the minimum and then we do these, and then every time, look, we have four neighbors, and each one we add it actually gets three more neighbors. Oh, yeah, okay. Um, we can just use the second row, and for white is also the second row. Our answer array. Um, for I is 2 in this one, so J is starting from 2. Y is greater than 0. J is equal to 2. Answer dot pushback. A should start from 2. So 2J. Yeah. And black is pushback. Oh, but they have to be connected first. So is it like this? Insert a pushback. We can use the previous or next. Yeah, I'll use the next one. So black is pushback. What is a pushback? 2? First is 1J and 1J minus 1. Wait, it's 3J, yeah. First dose, definitely. And since we're going to this place, so we have, so all of these are cleared, let's say. If all of these are cleared, only this one is remaining. So the first one, back dot push back 2. And then E and W both minus minus. And we can put our otherwise, it's gonna be except now we start from 3. I think this will result in the maximum possible amount of remaining indices that we can use. Oh, wrong thing to test one. Mm, expected integer, but yeah, it's found. Wait, why is there only two for this one? Oh, because over here it's w minus minus. Okay, yeah, it's probably test 17. 18. Accepted, okay, nice. So now, try that. First, three integers, int n, m, and k. Yeah, that's right. Okay. How do we approach this right now? Suppose these are TLs. Runtime here. I feel like it's just a Floyd Marshall, but changed a bit. So basically, what we have to do is keep track of our first case smallest values, and in the end, you can just output. Well, keep them in multi-set, I guess. And then in the end, we output the last element or the greatest element of the multi-set, and then we're done. Floyd Marshall is n cubed, right? Yeah, it's n cubed. We don't necessarily need a distance between every two vertices. Can we use a updated Dijkstra? Would that like be easier? And keep a map int. Let's try it. Let's try it. So the distance is 1 unit. So I guess we'll need long blocks. Vector here adjacent and for internal 0 smaller than n by plus into u v w u pushback minus v w adj v pushback u w. Okay, that's insert 2018. And now for a starting node, map inked long. We don't need these ones actually. We only need these. So we have the distance, Q into Q, Q dot push I, from I to J and from J to I are counted as 1. Y Q dot T. And in the end, we can just output it's dot right B. If, well, Q dot curve is equal to Q dot front and Q dot pop for int next is P dot first, long wait is P dot second. If wait plus MPI is greater than, stop right here. Otherwise, Q dot push next and MP next. Greater than PI, make MP next. That counts next. Yeah, that stuff. Otherwise, we can just erase this step. Try it. Probably with TLE if I send it though. infinite loop. Oh, n plus np curve. 2. Something wrong with my implementation. I want to see if any zeros are added to. No, okay. 1, 1, 2, 2. Next one should be 3. Or I counted the same path multiple times. Yeah, counted the same path multiple times. Oh, 3 and 10. More than or equal to I is not fine, okay. We'll go from small to big, and each path only gets counted once. Two nexus are to count if we don't count again. So I'm just making a this array. So you can. So we're starting from and then we're adding different views. What's wrong here? Visited counts this, so we already visited, we continue, and later on we add this to the vis. over here. Like, can't count duplicate paths. Can't count duplicate. See every element you pass. 1, 1, 2, 2, 4. So we never count 1 and 2 together. That's what we're doing. So we never count 5 to 6. Yeah. It's never even reaching higher ones, the higher levels. I I 0 and do all these and that's 1. And when 2 only go to 5, 2 only goes to 5. But 2 never even reaches 6. But it should reach 6. Yeah? Because 2 reach 6 is 2. Oh, okay. Oh, this plus 1 is 3, 6. So 2 reach 6, and 2 reach 3, and 2 reach 5. And then 5, when we went from 5, we never did 5 to 6. That's the problem, okay. So what we're doing, we're only visiting so many edges at once. And we can't do smaller than we're equal to, right? Yeah, okay. So I got 15 minutes. Every node, can we look at the paths that we found and then find some way to concatenate them together to make a final path? So basically we look at the edges we map and then we look if we can add them together, and if we can, that's great. Um, so basically distance and distance. Yeah, we tried. P dot second, P dot first. Sort all vowels relating to 0 as vowels of size. I plus right J changes vowels. So equal plus if vowels I dot first plus vowels J dot first is greater than equal to let's right begin break. Yeah, otherwise if this that IJ break right continue. Otherwise it's just S dot erase S dot end and this gets inserted. We're using map for the total distance. So it's like a better version of this. This counts this. This this IJ. path. Keep current path. Over here's current path. Path. If it's I, just continue. We don't need it anymore. But it just gets checked already, but just as a precaution. Sort all values, and once we get to here, values.count this stock count min, this stock count ij, and this ij is greater than or equal to Curtis. Continue. This else. Discounts and s dot erase. S dot fun. Discount ij. This ij. Mhm. Yeah. Still 11224. No J is vowels J dot second. No I. No J. J. Here. 2 because I have 0 right there. I shouldn't have zeros. Why did I get zeros in there? Oh, then we're equal to. Yeah. 1, 1, 2. There's another 2 here. Yeah. 9? Okay, good sign. This will probably TLE. Oh, test 13? Kinda like sound test 26, okay. How many tests are there? Can I use pragmas? Will that work? Wow, only 2 people got time to exceed on a really high one. I'm probably really close though. Otherwise it wouldn't be such high TLE. Try it on an order map. Oh yeah, it doesn't have the variant. Ever go to Long Long? Like, will we ever need this Long Long? You know what? How about this? We're not gonna use Long Longs. And we can change this to one order. Or, 2. Is that X029? That'd be better. It will never pass 29. Yeah, okay. Turn to 7. So you do need Long Longs? I'm gonna tell you, I was gonna tell you. Mm, practice. Forgot what the practice were. Advanced vectorization. This one. Or is it this one? Oh yeah, this one. So I feel like I have to change this map to an order map. Um, so Lancaster on test 7. So accepted. Oh, wow. Factorization really helped. Well, that TLE unpacked, so maybe. Okay, so, let's say full stop, yeah. Alright. Uh, now I'm gonna explain my solutions, I think. Okay. So, um, for problem A, all I did was I brute forced for every possible pair for Alice and Bob, and then I split the remaining one so they have like about the same amount of candies, and then I just choose the max between them. So there's three ways. First way is A and B, or and second way is A and C, and third way is B and C. And if A is greater than B, I just swap them, so Alice gets the last one at first, but it's the same thing. Here I calculate the difference. If the difference is less than or equal to the remaining one, then that means we have extra left over after giving them all to A, so we can do this. Otherwise, we can do A plus C. Okay, and then problem B. Problem B, so first I did mod 2 on each of them because realize it's odd, right? So we only need the parity. And then after this, I found all the positions where there's only one element, where it's equal to 1. So all the positions with odd elements. And then if the position is, if the total number of odd elements is smaller than k, then it's no automatically. Or if the size of the odd mod 2 is not equal to k mod 2, so the parities are not equal, it's also no. Because for example, if we have a sequence, for example, 1, 0, 0, 1, 1, 1, oh, just 1, and then k is equal to 2, you'll find that there's no way to do it because if we choose 1 here, then we have to choose these, and we can't do that. But if it's k equals to 2 and it's 1, 0, 0, 1, 1, 1, then we can do it. So we also have this condition. And then we can just output yes. I outputted the first k minus 1 odd ones. So guaranteed there are already k minus 1 segments. And then since this takes care of all the no's, it must be yes, so we can just output n at the end. So the remaining elements form their own, how do you say it? Own segment, yeah. For C, all you have to do, you calculate the boundaries for X and Y. So the least possible, max possible, least possible, max possible. For each of the ones, if F1 is 0, which means you can't go left, so there's a boundary for the left one. The second one is, so you can't go up, so there's a boundary for the maximum Y you can do. For F3, it's basically you can't go right. So there's a boundary on the rightmost value of X. And F4 is there's a boundary on the least possible value of Y. If the least possible value of X is greater than the highest possible value of X, or for Y is the same thing, and there's no answer. So there's no possible point, so you output 0. Otherwise, you can just output LXLY. Okay, for D1, D2, what I did was I had these three values, so SR, SG, SB. So basically, if you start from R, start from G, and start from B. By start from, I mean the first letter of this cycle is like R, and then or G or B. Then I first calculate them for the first k elements, and I have the answer for those. This is just casework, simple casework. And then for every I from k to n, what I did was I increment these by the current amount, and then for the previous I minus k, which we now don't need, we can subtract from. and then calculate the minimum answer for that, and we can output it. That's for D2 also because it's ON. For D1, you can just for every substring of length k, check for every possible cycle. For example, we cycle starting from R, G, and B, and then you calculate, and then you find the minimum answer for all of those. Um, for E, for E, it's just a constructed problem, so you have to realize that. So if we draw a line over, so while B and W, right, we take the minimum of those. For example, right now, is if black is the minimum, then what we can do is we can do this. For example, black is 3 right now, right? And then we will have the maximum possible of remaining white vertices for us to choose from. And that's basically what we did here. So all we did was we made the B black vertices, and then while we do that, we add like the white vertices, and while we do it, we add the extra black ones to here. And then in the end, if we can just put these vertices in a black and to our answer, and we can just output it. The same thing goes for white. And for F, what I did was so I had a distance for every pair of vertices. Um, I had to use a hash for this, and for every single starting node or root node, if there's like if it's a tree, but it's not really a tree. It's more of like a temporary vertex, or the vertex that we must pass through in this path. I have a queue, I have the distance, I have a set of this, the nodes we visited, and over here, basically, if it's a better path, then we choose it. That's what all of this is. For every neighbor, we check if it's a better path. If it's a better path, then we use it. If it's not, then we don't. And then for over here, so basically over here what I did was I put all of the pair values inside this files. So all of the nodes we visited, we find the distance to this I, and then I put them in this vector. Okay, and then I sort these by distance, and over here is the exact same thing as this basically. It's still if it's a better path, then we use it. If it's not, we don't. And then in the end, I output s dot right again. Uh, I had to use pragmas to pass it, and it only passed barely. It passed by 150 milliseconds. So that's probably not the correct solution. But it's good enough to pass, so that's fine. I'm fine with it. Okay, yeah. How did we do? 82nd place. Nice. Yeah, I got a lot of answers. Alright, so this concludes my recording of screencast. So bye.